So, a ground fault alarm has appeared on your battery charger. In the first video of this series, we discussed several ways that ATevo both indicates the presence of a ground fault and provides information about the location and magnitude of the fault. This video will demonstrate a simple but very effective second step to ground fault identification: isolating the charger from the DC bus. Good news! A ground fault alarm being on does not mean that your charger is malfunctioning. Most likely, it's working properly and has correctly detected a ground fault somewhere along the DC bus, which could include the battery or one of the DC loads. Our second step to ground fault identification will tell us for sure whether the fault is in the charger or if it's along the DC bus. We are going to isolate the charger from the bus and see what happens to the ground fault alarm. How you isolate the charger from the bus depends on your charger and how it's connected. If you have a DC distribution panel, the easiest thing is for you to open the breaker to the DC bus. If your charger is connected directly to the bus, and you have an ATevo with the small 5054 enclosure, open the DC breaker on the charger. If your charger is connected directly to the bus and it is one of the larger enclosures, such as the 5070, remove the DC output wires from the I/O panel on the charger. All three of these methods accomplish the same thing. The charger is now isolated from the DC bus, so its ground fault detection circuitry can no longer detect faults that may exist on the DC bus. For our demo, we'll work in our substation. It includes a distribution panel that connects an ATevo battery charger to a DC bus that has a 24-cell, 48-volt battery and a simulated load. By creating a ground fault in this substation, we will see how effectively we can narrow down the source of the ground fault when we isolate the charger from the DC bus. Okay, our charger shows a ground fault alarm. We're going to isolate the charger from the DC bus by opening the breaker that connects the charger to the bus. Let's see what happens as soon as it opens. Notice that the ground fault alarm LED disappeared when we isolated the charger from the DC bus. Because the charger no longer sees the bus, the fact that the ground fault alarm is gone tells us that the ground fault is not within the charger, but it exists somewhere along the DC bus. And for our demo, that in fact is true, as we created the fault by shorting a wire within the simulated substation load. We've just covered the second step to ground fault identification. After verifying that a ground fault alarm exists and looking at the information that the charger provides about the fault, we isolate the charger from the DC bus and see what happens. In the first case, if the ground fault alarm remains, the ground fault may be in the charger. Contact HindlePower's technical service team for assistance. In the second case, if it disappears, as it did in our demo, then you will need to begin more advanced troubleshooting techniques. For doing so, we recommend that you consult application note JD5032-00, as it discusses many possible sources of ground faults and gives you tips on how to determine if they exist. That concludes our video. We appreciate you watching and hope that you found it useful. If you have questions or feedback, please reach out to HindlePower through the contact form on our website to obtain service procedure JD5032-00 or to get assistance from our technical service team. We would love to hear from you. Have a great day.